Hello everybody, I am Sandis again, and I am here to present you and explain the bubble sort algorithm. It's a very simple algorithm and it's very known in the theory of sorting. So let's begin. To explain it, I'm going to take a simple example. It's numbers, 5 numbers, 7, 2, 8, 5 and 4. They are not in a right order, so I want to reorder them in an ascending order. The first rule in the sorting algorithm, the bubble sort algorithm, is to compare each element with its neighbor to the right, of course. So we will begin from the left. Here 7 is in blue, so we will compare each element to its neighbor to the right, and then if they are out of order, that means they are not in an ascending order in our case, we will swap them. If not, we will pass to the second number, that means 2 in this case. Okay, let's begin. We will execute the bubble sort algorithm now for this file of numbers, and you will understand it. So we have 7. Is it lower than 2? No, it's not. So we are going to swap them, and then we will pass to 8. 7, it is lower than 8, so it's okay, we keep them. And then 8 is not lower than 5, so we swap them. And same thing for 8, 4, we swap them. This is the first loop. Now we should do another loop and come back to the beginning, to the 2. As you see here, it's in blue. Then 2, it is lower than 7. 7 is not lower than 5, so we swap them. And then same thing, 7, 4, we swap them. And then 7, is it lower than 8? Yes, we keep them. We go another loop. We have 2, it is lower than 5, so it's in an ascending order, everything is okay. Then 5, it's not lower than 4, so we swap them. And then we have 5, 7, it's okay, we keep them. And 7, 8, we keep them. We go now to the fourth loop. We have 2, 4, it's okay. Then 4, 5, it's okay. 7 and 8, we have an ascending order and everything is okay. So now we pass to the code, the algorithm. Here I write it in C++. So we have our function. It's called, as you see here, bubble sort, and it takes as an argument A. A is our array. As you see here, our array is composed of 5 elements. 7, 2, 8, 5, 4. Okay. Here I have some remarks. So we have n. Let's call n is the size of our array, and we have 2 loops, as you see here, an outer loop and an inner loop. This inside is the inner loop, and this one is the outer loop. As you see, the outer loop is executed n minus 1 times. Let's say n times, because we 1 is negligible in front of n. So each time the outer loop is executed, the inner loop is executed n minus 1 time at first. Linearly drop it till just 1. So the average will be n divided by 2. And we will have, as a result, the complexity of this algorithm is going to be the complexity of the inner loop, multiplied by the complexity of the outer loop multiplied by k. K is this condition, if this condition is achieved or not. So we will have n multiplied by n divided by 2, and then multiplied by k. This is the complexity of our algorithm. So another question maybe it crosses, or I'm sure that it crosses your minds, is when we stop these loops. So here we have, as you see, go back to our example, we have 4 loops, but why we did only 4 loops? Why we didn't stop in the third one or the second one? Okay, good question. Actually, we run the loop in order to change things, right? So oddly enough, what is usually most important in understanding a loop is finding an invariant. So what is the invariant here? Is the condition. If this condition is achieved, so everything is in the right order, in the ascending order in our case, so it's invariant, so we stop. If there is something not in the ascending order, so we must keep looping till obtaining the right ascending order. So that's why we have to stop. That's when we have to stop, sorry. Here is this is the bubble sort algorithm and its complexity, and of course when the condition when to stop. If you have understand everything, or if you haven't understand any something, or you have missed something here, you can keep asking. You can comment under this video, and you can also contact me. These are my contacts on my email or on my Skype or phone. I will be there for responding to your question. And thank you. Goodbye.